Good afternoon, class.
Good afternoon, madam.
Have you ever used the GPS?
Yes.
Suddenly it tells you to turn left,
Yes.
right, where there's no roads, okay?
Yes.
Or it skips parts of your routes, like something missing. That kind of what happened in there when we graph rational function. The graph might have unexpected breaks or gaps where it suddenly jumps, shoots off the pages, or even disappear completely. Today we are going to figure out exactly why those breaks happen, and now we can predict and sketch them. So this is our learning outcome. At the end of the class you should be able to draw the graph of a rational function. You know this is the rational function, a quotient of ordinal functions, okay? Fx is equal to bx over gx, when gx is not equal to 0, which means that this one cannot equal to 0, okay? This one. The domain of a rational function is the set of all real numbers, except the dx values that make the denominator 0. So if you see this is a polynomial, but if the graph is 0, if the denominator is 0, then you can't show the graph of it. Okay? So these are the steps. There are 4 steps to sketch the rational function. We know that the rational function, it looks like this. Okay? Fx equal to b of x over q of x. P of x is anyone know what is this one? Numerator. This one is the numerator, and the other one? Denominator. So this is the step. This is the steps for sketching the graph of a rational function. The first one is to find the x-intercept. For finding the x-intercept of a rational function, you must equal the numerator equal to 0. Like this, let's say number 1. Let's sketch the graph of x minus 3, x plus 1, over x minus 1, and x plus 2. This is the example of a rational function. Okay? The first one, finding the x-intercept by making the numerator is equal to 0. For example, this one is a numerator. Okay? Yes. For finding the x-intercept, you use the numerator to equal to 0, and then you solve to find the x value. So what is the x value here? X minus 3, x plus 1 is equal to 0. What is the value of x here?
X equal to 3.
And this one?
X equal to
Negative 1. These are the x-intercepts. Now, the second step is to find the y-intercepts. For finding the y-intercepts, you must let x is equal to 0. This one, find next. The second step, find y-intercept. For finding the y-intercept, we must let x is equal to 0, right?
Yes.
Following class?
Yes.
Y is equal to 0 minus 3, 0 plus 1 over
X minus
0 minus 1 and
0 plus 2.
Okay, times this one, negative 3 times 1,
Negative 3.
negative 1 times 2,
Negative 2.
negative,
Positive.
3 over 2 is equal to, same
1.5.
1.5. So now we We know how to find the x-intercepts and the y-intercept. The next step is the vertical asymptotes. For finding the vertical asymptote, we must setting the denominator equal to 0 and you solve for x. Which one is the denominator here?
Denominator x minus 1.
X minus 1 and
X
plus 2. So, for finding the vertical asymptote, the denominator is equal to 0. X minus 1, this one is the vertical asymptote. X minus 1 and x plus 2 is equal to 0. What is the value of x here, class?
X equal 1.
X equal 1 and
equal -2.
very good. Good job. Okay. For the last one, for the horizontal asymptote, there are 3 possibilities. Okay, so you must study the words, the function, like this one, the bottom heavy function. Bottom heavy function means the denominator, the degree of the denominator is greater than the degree of the numerator. Is that clear? The degree means the power, the exponents.
Oh.
Yeah? The exponent, I mean the degree of the variable. The variable is any letters that represents the missing numbers. Okay? So this one is a variable. If you times x by x squared, x by x squared, this is the main important thing. You must work with the degree of the variables, right? The degree of the numerator and the degree of the denominator. If this one, like number 1, the bottom heavy function, this one is the bottom heavy function.
No.
X squared and x squared, power 2, this one is same, okay?
Yes.
So this one is not an equal, it's not an example of a bottom heavy function. Is that clear?
Yes.
And the second, so we cannot use this one. If the numerator is less than the denominator, then your horizontal asymptote is y is equal to 0. That means the x-axis. Okay? We know that's the y-axis. This is the x-axis, and this one is the y. A y asymptote. Y is equal 1, y is equal 2, y is equal 3. Right? This is the y asymptote. And the second one, so we cannot use this one, okay? Because the bottom, this one is the bottom heavy function. And our question here, our example here, maybe it's this one, okay? The balance function. Like this one, same degree with the degree of the variable in the numerator and the denominator. Is that clear?
Yes. Balance. Equal.
So what if the function is balanced? I mean the degree of the numerator and the degree of the denominator is equal. Then you must take just like this, the horizontal asymptote as an equation y equal to a over b, which means that you must take the coefficients of those variables, okay? Like this one, x squared over x squared, what is the coefficient of this one? 1. If there's the 2 here, what is the coefficient? What is the horizontal asymptote for this one? 2, okay? 2 over 1. Understand?
Yes.
Is that clear?
Yes, madam.
if 3 here, what is the horizontal asymptote for this graph, for this function?
2
2 over 3. Good job. That's means you must take the coefficients of the variables. Okay. Okay. So we know now that the horizontal asymptotes. Okay. What is our horizontal asymptotes here?
2
For this one.
that one.
The first one you must times this one and that
Yeah.
one, x squared
X squared over
x
6 squared.
squared.
Oh,
What is the coefficient?
1.
1, okay? So the horizontal asymptote
Is 1.
is 1. So the third part, the top area function, which means that the numerator is greater, the degree of the numerator is greater than the degree of the denominator, okay? So we must not, we did not use those two, okay? Anyway, we all know our points. Then the last step, you gonna point your graph. You're gonna sketch your graph, okay? This is a y-axis, this is an x-axis. What is our x-intercept here? 3 and negative 1.
3.
1, 2, 3, and
Negative
negative 1. Negative 1. Plus, this one is positive, negative on the x-axis. That's the y-axis. This one is positive and go down the negative. What is the y-intercept here? 1.5.
1.5.
1, 2, somewhere here. Okay?
Yes.
This is 3 over 2, 1.5. The y-intercept. The vertical axis, 1 and
1 and
2, negative 2. This one, you know the vertical axis, just like this.
Yeah. It's got on the X.
And negative 2, this one here, okay?
Yes.
And the horizontal asymptotes,
1.
1. Down here. Then you train up your points, and that's your graph. You have a point C, I guess?
Yes.
So it might look like this. This one and that one. You must get like this. And for finding the other parts, you know the graph of a rectangular graph, okay? The fourth quadrant and the second quadrant, okay? So this one must base here, somewhere here. But if you confuse either, you must point that, you must get like this, okay? You must substitute the x maybe negative 3 inside the function, and then your y-axis. Then you can know your y-axis. Like this. If this one is negative 3, let's substitute in here. Negative 3 minus 3, negative 3 plus 1, over negative 3 minus 1, negative 3 plus 2. Yeah, when we sub negative 3 in the equation, then our answer is positive 3, okay? Somewhere here. That's why our graph kind of looks like this. Understand?
Yes.
Any questions?
No.
If you don't have a question, I have a question for you. You? Which one is the numerator here?
X minus 3, x plus 1.
And you? How to find the TX intercept?
We're gonna let the numerator equate to 0.
For finding the TX intercept, yeah. Okay, class, this is your homework. I will change tomorrow, okay?
Thank you,
Thank you,
madam.